We started off this chapter talking about rate of change and slope, and we found out that we can calculate slope from a line that's graphed on the coordinate plane by counting the boxes of rise over run, and we also used the slope formula, m is equal to change in y over change in x, in order to find our slope. We moved on to lesson 5.2 and talked about the model of direct variation, y is equal to kx. We found out that k is our constant of variation, which is also our slope, and that the graph of a model of direct variation will pass through the origin. So on to lesson 5.3 today. In lesson 5.3, we're going to investigate the slope-intercept form of a line, y is equal to mx plus b. We're going to write linear equations given different information. We're going to start off with being given the slope and the y-intercept, which are the two key elements of a slope-intercept form of a line. We're then going to practice writing the equation when given the slope and a point on the line. And lastly, given 2 points. Let's get started. Given the slope and the y-intercept, can you write the equation? The answer to that should be yes. If we use the model, y is equal to mx plus b, and we already know that m represents my slope and the variable b represents my y-intercept, I simply replace those into the model. So we have successfully written the equation. Let's just practice a couple more. Y is equal to 5x minus 1. Third one, y is equal to 2/3 x plus 0. Well, I don't need to write the 0, and if you recall, that's our model of direct variation. And the last one, our slope is 0, so 0 times x is 0, and this leaves me with a constant. And when I graph that, it will be that horizontal line right here at -3, because y is constant. So if given the slope and the y-intercept, we can very easily write the equation. What happens when you're given the slope and a point on the line? Can you write the equation? Not right away. What do we need? We need to find our y-intercept. We're missing b. So we'll replace into the model what we have and solve for b. If my model, once again, is y is equal to mx plus b, and I have a pair of coordinates or ordered pairs, my -2 is my y, my m is -3, the x is 4, and we're solving for b. Let's simplify, and we'll perform one inverse operation here. We'll add 12 to both sides. We'll see that b is equal to 10. Now that I have a y-intercept, I can go ahead and write the equation using the slope that was given and the y-intercept that we found. And done. A second problem of this same type, we'll substitute in the values y is equal to m times x, and we're solving for b. Well, 1/3 of a -6 is -2. We'll add 2 to both sides, and that will give us the value of b. On to writing the equation. Y is equal to 1/3 x plus 4. So when given the point and a slope, we can easily calculate and find our y-intercept and write our equation. But wait, there's more. What happens when you are given 2 points on the line? What do we need? We need to find our slope. We need to find our y-intercept. And lastly, we need to write the equation. So let's begin. Our slope formula, if you recall, m is equal to change in y over change in x. Let's simplify. We get a slope of 2. Now we have a choice. We can use the first point or the second point. I most of the time go to the first. And I'll take this x and y, and I'll use the slope and find my y-intercept. So y is 6, which is equal to the slope 2 times x, which is 4, and we're solving for b, just like we did in the previous set. We simplify, and then we isolate b, and we find that b is equal to -2. We can write the equation now because we have everything we need. Y is equal to 2x minus 2. Let's try one more of this type. Setting up our slope formula is the first order of business. 9 minus 4 over 8 minus a -2. We'll simplify, and we'll get 1/2 as my slope. I choose one of the 2 points. Most of the time my go-to is the first point. It doesn't matter, you'll get the same y-intercept. So I'll get 4 is equal to 1/2 of -2 plus b. You then go ahead and solve this equation for b. We get b is equal to 5. If you have a slope and a y-intercept, you have an equation. That equation will be y is equal to 1/2 x plus 5. That is just pretty much the basic type of problems that you'll encounter. There is one more here for you to try, and this is another given 2 points. Start off again by finding your slope. So if you can do this one, you can do all the others, because this is the more challenging one because it has more parts to it. Being careful to set up your slope formula correctly. This is good practice for the midterm as well. We go ahead and we'll add the opposite. That'll give me -10. Add the opposite. That'll give me 10. So I simplify, and my slope is equal to -1. Choosing a point, I'll take 5 is equal to -1 times -6 plus b. Inverse again, subtract. B is equal to -1. If you have a y-intercept and you have a slope, you can write the line. Y is equal to, well, -1 times x is just -x minus 1. And there you have a third example of that type. And that's the 3 different ways that we'll be writing linear equations in slope-intercept form. Before I end this video, I did want to mention one other way that we could write that equation in slope-intercept form. What if we were given a line that's been graphed for us? What information do we need in order to write the equation? Well, we need slope and a y-intercept. Identifying the y-intercept on a graphed line is very easy. We find a point that lies on the y-axis. 1, 2, 3, 4, 5. My y-intercept is 5. Now comes the slope. Remember, we can calculate slope, as we did in the beginning in section 5.1, by counting rise over run. This is a positive slope, and it counts up 1, 2, 3. and over 1, 2. That's exactly what I need to write the equation. I have slope, and I have an intercept. So I wanted you just to see one quick example on how you can write the equation if you were giving a line that was already graphed on the coordinate plane. And now my lesson's done.